Good afternoon, good evening, everyone. There's actually more than one of you. Oh, look, we have small Daniel, and then that's big Daniel. Big Daniel, small Daniel, big, small, yeah. Just for the camera. Thanks for coming. It's the last talk of the day, and you are coming to a security talk. Are you crazy? What are you doing? Hopefully, I keep you, still entertained, alive, awake. We'll see. So, hi. For those who don't know me, I'm Daniel. I work in the Spring team at Broadcom. I work in the Spring commercial team, where we do applied Spring. Take Spring libraries, build products, and then we sell those products to our customers. And on the open source side, I do Spring Security. I'm the European guy in the security team. So Spring Security, Authorization Server, and all of those projects. Here are all my social, my internet. I'm on Blue Sky. Thanks, Patrick, for mentioning Blue Sky. Great social network. Please go there. I'm also on the web. I'm on GitHub. I'm on LinkedIn. I'm on email. If you're watching this on YouTube, feel free to send me a line. I'm always interested in your crazy problem and security setups, because we get real feedback of actually what you're doing. If you're at the conference, come chat with me. Interrupt me when I'm having a conversation. It's a pleasure to have this. Last year, I was here. I did this. Who was here last year? Hey, probably 10%. So the first talk from last year was about authentication with Spring Security. So logging in, knowing who the user is, knowing data about them, and how this is all architecture and how this all plays out. And speaking of feedback, after that session, a lot of people came to me with their weird corner cases of how they use that, and they had a lot of questions about authorization, about permissions. Oh, my users, they log in with a form login and also MTLS, and then these are different permissions and so on. So, I made part 2. So if you're watching this, feel free to take a look at this one. It's a good intro. We're not going to go over the concepts that we see in this one video here, but we're going to do part 2, return of the authorization. So I always like to start with a small demo so we can talk about something together. And then most of what we're going to be doing is live coding. 2 big parts. One is mechanical stuff, like the toolings, the APIs that Spring Security gives you to do authorization. So some of this you will already know, and then some might be new to you and might be interesting for new use cases. The second bit is less of an API thing, and it's more about thinking about authorization. Because if I give you all the tools you need to build a house, it doesn't mean you can build a house. So the second part is a little bit more out there thinking, OK, how can we apply this into real-world use cases? So without further ado, demos, code. Last year, I dedicated my session to Dr. Subramaniam Venkat, removing my shoes. I think this year, many demos, too much content, got to speak really fast, so I dedicate my session to Josh Long. Spirit of Josh, help me succeed in those demos. All right, here we go. So there's an application here. And it kind of looks like last year's application. Similar, OK. Take them bigger here, maybe left. Right. So it has a public page, it has a private page, and I can log in. So I'm going to have 2 users, and they're different. Perfect. And then on the right, Josh, password. If I can type. There we go. So Daniel on the left, Josh on the right. And the only rules is I can log in with a form login, and then I must be authenticated to see this page. And there's a bunch of rules that we're going to implement here. You've probably done this already. So here's my app. I have a few users. I model my users with a custom object, so demo users. So we have Josh. Josh has an email, josh@example.com. And Josh is the only admin of the app. How's the font size in the back? Is it good? Yeah, in the back? OK, nobody's screaming. I can make it bigger if you need to. But actually, you know what? For the shy people out there we go. So Josh is admin. The other people are not admin. Daniel at example.com, simple user. And then we have Alice and Bob. Alice is at corp.example.com. And then Bob is ext.example.com. And that's the difference. And so they can log in with their username and password in a form. And basically, the public page and its dependencies are public. And then the rest, you must be authenticated. So the first rule we want is there's this admin page. And I want admins to be able to see the admin page, but I don't want Daniel to be able to see that page, because Daniel is a regular user. So if you've used Spring Security, you've probably already done this, right? So we do auth, then request matchers, and we say the admin page hasRole admin, right? And so with this, now when the app reloads, Daniel cannot go to the admin page. Josh is admin, so Josh can see the admin page. So request, we look at the endpoint, and we put some authorization. Now on the main page, on the private page here, at the bottom, I have some shipment information. There are currently 4 shipments. Comes from a database, it doesn't really matter. Now I want to protect some of this at the method level. So that you've done probably already as well. So instead of looking at endpoints, you can enable method security. And then our demo controller here has a shipment repository. It uses the count method. And maybe this count is only for admins. So you can go here, there's the count method, and so you can apply security here. So pre-authorized, hasRole, admin, similar. Cool. So in here, Josh can still see the page after I reload, but then Daniel gets an exception, 403, because it's forbidden. That's not great. I'd rather want to hide the shipment information and keep the page not broken. So I could like wrap this, the count method, how this is called. So we could take this and then wrap it in a try catch. And then I can take any exception. This is an authorization denied exception. I don't really care about it. And then I'm not going to do anything. So I'll have null in my template. And this is fine, isn't it? This is fine. Cool. So with this, if this blows up, no shipment count in the template. So now Daniel can see the page, but Daniel cannot see the list of shipments, right? So that you've done. Simple, not crazy. There's an interesting point about this code, though. The model for authorization in Spring Security is separation of concerns. So the idea is, in here, you're doing your security rules in a dedicated space, not in your code. So this is not your code, this is configuration code. Same goes for the shipment repository, right? Here, party, come on, this one maybe? Yep. Ooh. Party. Here we go. So look, no security code here, right? I kind of cheated though, right? Here, this is fine. Is it really fine? Probably not. To do, fix this later. We'll think about this. But the main model is this, right? I have annotations to declare what I want, and I have dedicated security code in my security config. So that's what you get from this demo. You've done this already. It's on the guides. It's on the reference doc. It's everywhere, and you can do this easily. So keep this separation of concerns in mind. This is what we're trying to achieve. OK. So now into the mechanics of all the things you can do with Spring Security. So the easiest one that people encounter first is this request level security. So we've seen in our security configuration here, there's a security filter chain. We do authorize HTTP requests, and then we make our rules. So this is an authorization, auth-z for short, decision. But when you think about it, this is also an authorization decision, because we're saying any page that's not declared here must be authenticated. And these things are also, auth-z decisions, because you're describing these pages are open to everyone. And so they kind of all look the same. You say auth, request matcher. The request matcher can have just a path, but it can have different signatures. So you can put a method, only the post on these path. And it can have more complicated stuff that reads the header, if you will. But the idea is like a request comes in, I look at it, and I decide something. And then you use these helper methods that Spring Security has for you. So we have permit all, authenticated, anonymous for only anonymous users, hasRole. We have like has authority. So authority is a kind of a higher level or lower level construct than roles. So it's a string, represents here in a role because it's prefixed by role. This is kind of similar to hasRole admin, except hasRole admin has concepts of hierarchy, right? Admin can mean it's also a user, but kind of sign of the same. So let's implement some rules with those. We have this page here, so profile Daniel, and the login name must match the username in the path. So I want Daniel to be able to see the profile of Daniel, but I don't want Josh to be able to see the profile of Daniel. Josh can only see Josh's profile. So let's do that. Can only see your own profile. So same thing, right? You do auth request matchers and then profile, and it has a username. Cool. And there's another method in here that's called hasVariable. So it has a variable username. That's the path in here. They're the same. So the username in the path must match something, and that something is equal to some string that is derived from the authentication. So auth get name, right? Ooh, not details, get name, right? Not auth, authentication. If I put auth, it clashes. Authentication. Cool, right? So, something like that. So the name of the user must match the name in the path. We can make this a lambda, fine. So now Daniel can see his own page. Josh cannot. So I'm restricted to my own profile like this. Now, this is basically everything that Spring Security offers for simple packaged use cases for you. But let's say I have a corp/corp page for corporate, and only users with corp.example.com email addresses can see that page. So here, Daniel and Josh can see it. How can we lock down? So take this, and we say restricted, or email must be in @corp.example.com. So with this, we say the request matchers of corp, and then in here, it's not a role. It's the email. It's an attribute. It's not role-based access control. It's more of an attribute. It's not a variable. It's not anything. So to give you flexibility in implementing your rules, Spring Security gives you access. Access here takes an authorization manager. This authorization manager is basically a lambda that takes an authentication supplier and then the request context. So the authentication supplier tells you who the user is. The request context tells you stuff about the request, such as the path, the variables, and so on. And so in here, you return a new authorization decision, true or false. Is it granted or is it rejected? So let's say we're going to reject everyone. And now we want to make an authorization based on information we have about the user. So we do authentication supplier get, that gives us the authentication object, so the identity of the user. And now we can say, well, if this authentication object .get principal is an instance of a demo user, you, and the user.get email, the domain of that email is equal to corp.example.com, right? So in here, we return a granted authorization. So yes, you're allowed to come here, true. So now only when the user is logged in and they have corp.example.com as their domain are they allowed to see that page. So now Daniel, after the app refreshes, Daniel can't see the page, Josh can't see the page. And so in here, if we log in as, say, Alice password, right? Alice corp.example.com, Alice can see the page. Okay, so these are the tools you have. But what if you want to make slightly more complex rules? So you can write very complicated authorization managers. You can write complicated methods that do many things. There's another way to do that, though. So all of these hasRole and these hasVariable, all of that under the hood is Spring Security using access and using authorization managers. So if you look at a hasRole here, it uses the access method that you can use for request matchers. If you look at the equal to, it calls access and then has this lambda here. So you can write these rules as authorization managers yourself. So for example, I've written my own. I've ported this equal to in a authorization manager they call name authorization manager. So to match variables. I just copied kind of the code that Spring Security has for doing that. And so it kind of works the same, right? The profile here, profile Daniel. Daniel can see their profile. Josh can't, right? Forbidden for Daniel, allowed for Josh. And now instead of writing complicated code that contains all of this, I can compose the rules together. So in here, we have a few utilities. Authorization managers with an S, any of, or all of, or not. So you can do all of Boolean logic, and you can say any of. So either it's my own profile, and I also want admins can see everyone's profile. So in here, I can use one of these authorization managers that Spring Security uses: authority, authorization manager, hasRole, admin, which is the same as this here. So now when any of the rules are true, either admin or it's my own profile, I'm allowed to see the page. So let's look at that. In here, Daniel can see the page, and then Josh, as an admin, can see the page too. All of these things, all of these access rules that we've put, they all look at the authentication object, so the identity of the user. But you don't need the authentication to make security decisions. So think about it when you're in an airport, for example. Can you get to the baggage claim area? Well, it depends where you come from. If you come from the outside of the airport, there's a guard, you can't get in. If you come from a plane, you walk down the corridor, and then you can get to the baggage claim area. We don't know anything about you. We just know that you came from the right place. So it's possible to make authorization decision based on the context of the request rather than the authentication. So in our case here, I have a rule saying this page must be accessed from localhost, right? So I have localhost here, and if I go to 127.0.0.1, right, I have to log in, sure, Alice, password. So in here, I want this to be forbidden. Like, I can't access this because it's 127.0.0.1. So how do we do it? Again, authorization manager. So can only be accessed through localhost. Auth.request matcher. So my endpoint is called localhost. Not very inventive. Access, and then this time I don't care about the authentication. I can just ignore it, and I say request context, right? And then now I can make a authorization decision. Return new authorization decision. We want the request context, we want the request, we want the server name, and we want this to be equals to localhost. Localhost. There we go. So now, on Josh is on localhost, so we can go to localhost. Even if I'm logged out, even if I go here and go to logout, right? If I go to localhost, I should be able to see the localhost page. It doesn't matter who I am. But Alice is logged in here, and she can't see localhost because she's accessing this through 127.0.0.1. So now the information here, the important information, is the context of the request. OK, let's log back in as Josh. OK, so request level, the few important takeaways, that happens in the security configuration, in the security filter chain. If you're in servlet, in the web security filter chain, authorize HTTP request, authorize exchange and reactive. And so we have simple rules. If you're doing role-based access control, hasRole, then you can authenticate, deny, easy. For more interesting rules, you do access. And so you can do a Lambda, or you can do a class. It works the same. It's a functional interface. And you can compose them together and saying, OK, I have reusable rules. And I say, that rule, all that rule, all that rule. The one thing you can't do, or you could do, but it requires much more work, is reading the body of the request. So in here, we're looking at the request coming in, looking at the metadata, the headers, and we are not looking at what's inside the body. So because if you read the body, then Spring and the dispatcher servlet will not be able to read it. So this is kind of like an early warning that you're looking at the request before looking at what's inside. If you want to look at what's inside, you will rather do method level security instead. So we've done pre-authorize, right? And now let's make a rule for another method. So we have this shipments, the list of shipments, and we want the email to be corp.example.com. So now Daniel and Josh can see them. We want to lock loading all shipments from the database from corp.example.com. So we go to our shipment repository here, and we can say at pre-authorize. And so what's here is not restricted to these hasRole, hasAuthority, and so on. In here, you can put any Spring expression, language expression you want. So you can access like static methods on your classes and so on, right? You can do anything in here. We provide a few helpers with this hasRole. It's in the security expression root here. You can access the roles. You can access the authentication objects, so the identity of the user, authentication. So these authentication, they have authorities if you want to have roles, scopes, and so on. They also have a principal, the identity of the user, get principal. So this is the normal authentication. Since we know you're going to be doing that a lot, we also have a principal, which is a short way to say authentication.principal. So in here, the principal, it's a demo user, so we can get the email, get the domain, and say, is that equals to, we said, corp.example.com. So now, in here, after this reloads, boop, I can't access it, right? But then Alice should be able to access the page. Password, right? And then shipments. So Alice has corp.example.com. So this decision you're making is pre-authorized. So if the access is authorized, the method is called. If it's denied, the method is not called. But that means you have all the information you need to make the authorization decision before actually calling the method, which is sometimes not the case. So for example, in here, we have another way of seeing the profile. So a different endpoint so we don't clash with this method security or endpoint security here. So here I want people to be able to see the profile of users who have the same email domain as them. So I should be able to see Josh should be able to see me, but I should not be able to see Alice because Alice is on corp.example.com. So in that case, if you look at your controller, it says blah, 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 method security here, right? And it says find user. So this find user method, I just passed the username. I don't even know if the username exists, right? So if I put, I don't know, Sergey here, right? I will get a 404 in the end. So I need to wait until the method is called to make an authorization decision. So here we do post authorize after the method is called. And so in here we can say, well, I don't know, principal dot get email dot domain equals the domain of the thing that's returned by the method. So in Spring expression language, that's called a return object. And in here, thanks to IntelliJ, I get auto-completion. I know it's a demo user, so I can get the email and then compare the domains like this. So with that, Josh can see Josh's profile, of course. Can see Daniel's profile, that's fine. But Daniel can't see Alice's profile because Alice is on corp.example.com. And you can write complex expressions here. So for example, put a text block here so we can put multi-line, say, or maybe I want to say, well, anyone can access this, say username, so I can access the variables that are passed here. So this variable matches this one. Username equals Bob. Everyone can see Bob's profile, that's fine. Okay, so with this, Bob is on ext@example.com, but I can still see Bob's profile because Bob is a fun guy, I don't know, whatever. So here, your expressions can get very complicated very fast if you have very complicated rules. And so if you end up with like 55 lines of authorization code here, you're doing it wrong. What you can do instead, so let's get rid of this Bob thing rule, and then in here we reintroduce this thing here. You can delegate your decision, or like the logic for making the decision, to a bean. So I have an authorization service bean, authorization service here. So it's annotated with @service. It's a bean. The name by default is authorization service. So in here, since this is a Spring language expression, I can do @authorization service. And so now I can call methods on that bean. I can do same domain between the authentication and the return object, right? So I compare the authentication to the return object by this bean. And the magic of this is here, say classes. I can write unit tests for this. Did you write unit tests? Yeah? Yeah, you should be writing unit tests. You don't want to be writing integration tests here, right, for this. You can, it's fine. You can write some of them, but if your logic is complicated, you can now write tests for these smaller things and reference them here. Now, one last use case is go back to the shipment page. So let's say, change my mind now that shipment find all, I want also users on example.com to be able to find them. So I can go back to my shipment repository and change the rule. And we said, well, this could be a text block, cool. And we say either corp.example.com or example.com. So both email addresses or email domains are valid, so now you can see the shipments. But then maybe I have different rules. Maybe I have some rules where it's only corp.example.com. Maybe there's some rules that it's only ext.example.com. And they kind of always look the same. So it'd be really, really nice to be able to do, say, allow domains, and then say domains equals example.com and corp.example.com, right? So this way, I can use this here, and if I want a different rule here, I can say, well, on this count, I want example.com, right? Reuse the logic. So it's possible with Spring Security with two things. So first, I'm going to create this annotation. Yep, perfect. Retention is runtime, because we inspect this at runtime. The target is method, but you can put it on a class if you want, that's fine. And then in here, you do your role, pre-authorize. I'm going to delegate to that bean that I have, authorization service, has allowed domain, it's the authentication. And so we need to pass the domains in here. So our annotation, we put a domain field or property, right? So in here, if I want to transfer this domains thing in my expression here, since Spring Security 6.3 last year, you can do templates like this. So you can pass the value of domains inside your pre-authorized spell expression. To be able to use this, you need to provide a bean. There's a flag for turning it on. So I'm going to go to this security configuration, and we're going to provide a annotation template expression defaults. Java naming is fun, and then return a new annotation template expression defaults. So by doing this, you turn on parsing this pre-authorized to inject annotation. And so now Daniel can see the shipments, Alice can see the shipments, but Bob should not be able because he's on ext. So Bob password. Shipments here, right? Bob has a 4.3. So with this, you can write your own annotations and make your own reusable security code that is not crazy. So you do your separation of concerns by writing your custom little happy annotations like this. Speaking of separation of concerns, we said fix me, right? So somewhere here, this is not great. So remove that. Oops. Right? We want to keep our security code in security methods. So I remove this. This should break for non-admins. Go here, go to the private page, right? So private page is here, right? So Daniel can't see that because when we call count, Daniel is not admin and it throws. Instead of wrapping this and bleeding your authorization things in your business logic code, you can annotate this with handle authorization denied. You provide a handler class, and this is a bean, so let's call it null auth z denied handler dot class. And then this class, no AI, no. There we go. No. Too easy with AI. So this must be a Spring Bean, and it has one method, either one method for pre-authorizing, one for post-authorizing. And so basically this says here, when the decision fails, return, and in our case, we just return null. So in here, now, poop, this fixes Daniel's page. So now all my authorization code is in annotations around my code. OK, last bit about these methods. So remember, we did a post-authorize on the demo user detail service here. Because we couldn't make the decision before. If you can make the decision before, please do not load objects for fun to filter them after the fact with like post-authorize or post-filter. In here, if you can, also do select something from XY form from XYZ, join users, where dot, I don't know, ID equals authorization or authentication.id, right? You do this. You are allowed to put post-authorize on top of it, extra security to make sure that if your query is wrong, it removes the authorization. But this is not made for business logic for like filtering. You don't want to load 1 million rows from your database and filter them after the fact. So TLDR, pre-authorized, post-authorized. There's also a pre-filter, post-filter for collections. You can put any spell expression in there, even complex expression. Avoid expressions that are too complex. They're annoying to test. Instead, you do a bean, you put methods in those beans, and then you delegate the decision to the beans. You can write your own domains, including tuple-length values, including multiple values if you want, right? You can have multiple properties in your annotations. And when you do post-authorize, please, 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 do not load stuff to filter them with post-authorize or post-filter. This is terrible, don't do this. And lastly, we have this handle authorization denied. Okay, last bit of mechanics, object level security. So this is fairly recent. Now, we have the shipments here. And these shipments, they have an address. And maybe this address is like PII. It's personal blah, blah, information. It's personal information. You're not allowed to see this. Only admins can see this value here. In Spring, you can go here in our shipments object, shipment, right? And then you can say, this address, I want to apply some rules. So you could do @pre-authorized and then hasRole admin. Only admins can see this. But if you do this, nothing happens. This is a plain Java object. Spring Security does not intercept the calls to the get address here. So no authorization is run. So after this reloads, Daniel can still see this. If you want this to kick in, you can go to the call sites, to the sites where these things are returned. And so find all here, you can say @authorized return object. This is going to look at all the objects that come out of here, and it's going to proxy them in a Spring proxy that does authorization. And so every time you call a method, we're going to check authorization on it. And so now, Josh can still see the address, but Daniel can't see that anymore. So again, we don't want a 4 or 3, right? We want some nice fallback maybe. So again, we go to the shipments here. We're going to say handle authorization denied, handler class equals redacted auth z denied handler, handler.class, right? And so now create this, yes, fine, sure, this is a component. And we want to implement the methods. And then in here, when someone calls this, we're going to return redacted instead. So instead of doing ugly authorization denied exception that we catch with a 4 or 3, we put redacted. So Josh, as admin, can see the address. I am not admin. I cannot see the address. I get redacted instead. So object level. You can apply security to methods now, which was very difficult to do. We've been able to do this for about a year now. Please consider this is adding proxies. So you're adding a layer of proxy. If you want extreme performance, this might be kind of a trade-off you don't want to be doing instead. Okay. So all of this is fine, but it's very tooling oriented. And it doesn't answer the original use case of like, oh, my users, they log in with MTLS and also form login, and I have different permissions. Now you have to assemble these things to do a use case. And so to think about authorization, there's many ways to do this, and you can do authorization based on roles, based on attributes, based on relationships. But like a more general framework to think about authorization, I went back in time, 2001, and I dug up XACML. Who knows what XACML is? Extensible Access Control Markup Language. 2001, we write lots of XML. So we're not going to be using this, but we're going to look at it to maybe inform our thinking about authorization. And they have this thinking of like when an action is performed. So here, Alice calls get on resource 123. There's a few points where some things happen in the application. And so the first point is the policy enforcement point. And this is where your policy, your authorization decision will be enforced. So at which point of the life cycle of the action. Then there's the decision point. We're going to decide, can Alice access resource 123, yes or no? And this is the policy decision point. So where is it? Is it in your app? Is it outside? Where do you decide this? And these are disjointed. They don't need to be in the same place. And then the last interesting bit is the policy information point. So this XACML framework had a thing where you could retrieve attributes of the object or retrieve attributes of the user to say, oh, resource 123 is top secret, and then Alice has security clearance level 3, so yes, you can access that. and it comes from this policy information point. So in Spring Security, we already have some things covered for you here. Oh, and also, yeah, it's 2001, so it's fun. You're writing beans in XML, and now you're also writing your security in XML. And so Spring Security has you covered for at least the enforcement and decision point. And the thinking about the enforcement is an important point. It says, do I want my request to be parsed? Do I want the body of the request to be parsed? Or do I have enough information to make a decision about the request when it comes in before even reading the body? Can I reject it just by reading the headers? So if you're doing authorized request, this is what's happening. Can I do before the method is called, pre-authorized? After the method is called, post-authorized. So you're deciding where in the lifecycle of the request the enforcement is happening. The decision is happening in these, so either in this .access call or in the spell expression here, but it can be within your app. It can be your own code that runs in here in a bean, but this thing can also call to external services. So if you're doing like OpenFGA or the Open Policy Agent, you can delegate your decisions to an external system. So Google does that with their Zanzibar paper for deciding, oh, I am part of an organization and this file is shared and so on. It's not within Google Docs. It's an external authorization system that can be refreshed over time. So every time you make a request, they check the authorization here. So you can also delegate to outside of your application. The last bit is the policy information point. So sometimes you can load information about your users at the moment where you're doing the decision. So in your access methods here, or in the annotations. Let's see, security configuration. In here, something is happening. So maybe you can do like, my custom info service dot load user data and authentication dot get ID or something, right? You can do something like that. But sometimes this information is lost. It doesn't exist anymore. It's not stored anywhere. So one use case with the MTLS thing. So imagine we have our page here. So we have a page, and I want this page to be only accessible through HTTP Basic. So no foreign login for that page. So only access through HTTP Basic Auth. So for this to work, I need Basic Auth or HTTP Basic to be enabled. So I do HTTP Basic with default, fine. So with this now, the main page is still valid, but now in my console, I can go here, and then I can do HTTP, AT-AT, HTTP-basic, and then auth, and then Daniel, password. So now I can access this from my terminal, not from the browser anymore. Okay. Now I need to apply this rule. So I do auth request matchers, HTTP basic, and then I put a access thing, okay? And there's authentication supplier, and then a request context. I'm not going to look at the request context here. Let's allow all the decisions. Authorization decision, true. Right? Everyone is allowed to call this page, fine. And then we do auth supplier.get. This gives us an authentication. And we can print it, right? And so, I don't know, passport. Is there a passport here? Passport. Yeah, well, fine. Authentication, and then plus authentication. So we can see the authentication that comes in. So, go back here, refresh. And now in my console, at the very bottom somewhere, try again, boop. Right, so in here we have the authentication. So it's a username password authentication token. I have a demo user here, and then I have some roles, fine. But it doesn't tell me it's foreign login. And if I do here form login, or HTTP basic, sorry, and I go to my console, in here I have a username password authentication token with the same user, with the role user, but I don't know that it's HTTP basic. It's not captured here because that was happening at the time the identity of the user was verified. So when I did the login phase. And so you need to capture that data at login time. And this is not necessarily consistent across all the ways you can log in with Spring Security. Form login, HTTP basic, one-time token, OpenID Connect. So for example, if you're doing OpenID Connect, a good place to transform the authentication of the user is this OIDC user service. OIDC user service, right? You can provide this as a bean. And in here, you can do return, new, my OIDC user service. And so if you're doing OpenID Connect, you can do some transformations here. If you're doing, say, HTTP basic, look at the HTTP basic thing. It does a basic authentication filter. This basic authentication filter, it does, it converts the request to an authentication, then it authenticates those credentials. And so possibly you could do stuff like provide your own static class or custom authentication converter, extend or implement, authentication converter, right? And so you could feed that into HTTP basic, implement methods. So this one takes a servlet request, produces an authentication. So in here, you can look at the request and say, oh, these were credentials from the header. It could be an authentication provider. And worst case, it could even be your own custom filter. There's one last escape hatch that's very useful for these small use cases. The result of logging in is producing an authentication object. So authentication, this one here from Spring Security. And so it has the principal, the identity of the user, so my username, my email, whatever. It has the authorities, the roles, and it has a useful little details object. So you can put anything you want in that details object. By default, we give you a web authentication details, which has the IP of the request coming in, but you can store what you want. So in here, you could customize your form login to capture that it was a form login using these details. So let's do that. Enum auth type, and so we'll have a form login, and then HTTP basic, right? And so we wrap this. Form login. It has an authentication detail source. So this is an interface that takes a HTTP servlet request and then returns whatever you want. And so in here we say, well, okay, we get a request, and then we're always going to return form login because we know it's a form login, right? Import, yes, fine. And then in HTTP basic, we want a lambda, so HB, and we do HB, authentication detail source, and in that case, when a request comes in, we don't really care about the request either. We know it's HTTP basic, so HTTP-basic, cool, right? So now my authentication object contains the information about the login. So in here, I can do if authentication get details. So this is an object, and I can say if it's equals to HTTP basic, then I'm going to return true, allow this request to proceed, authorization decision, true, and then otherwise, I'm going to return false. So now it's in two phases. You're thinking, oh, what information do I need? When is this information available? What transformation can I apply to the process to extract and save this information here? So in here, if the demo gods and Josh Long are with me, this page should get a 403. And then if I do it in my console, I should be able to see the page. Because when I log in, I capture this information, and then I can make the decision after the fact. There's one little twist to this, which is if I go here to a new browser window, and I try to go to localhost HTTP 8080, and I try to go to HTTP basic here, so here, right? So I should get a 403 because I'm not doing HTTP basic here. But instead, I get redirected to form login. This is because by default, when I apply a form login with Spring Security, if you look deep in the code, in this form login here, it has a form login configurer, which extends an abstract authentication filter configurer. And so in here, in the end, we're going to set a login URL, so we'll entry point. So if I'm not logged in and I get an authorization denied, then I get redirected to the login page. But in our case, in HTTP basic case, it doesn't make sense because if I log in, so here, if I log in Alice password, then after logging in, I get a 403. But I could have known that before. There was no basic authorization basic header, so this was not allowed anyway. So I could go and like, oh, well, OK, I'm going to change my security configuration here. And then this is handled through exception handling. So I'm going to do exception handling and then set the default authentication, blah. Complicated. And so now all these rules, they interact with each other, and they're complicated. And so I'm going to start growing a monster that I want to avoid. But I know that HTTP basic, it's only HTTP basic. It's not the other requests. So the last thing you can do is say, well, I have a precise set of rules, and I want to apply them only here, only for HTTP basic. So no form login for this page. So one thing you can do is provide a separate filter chain that has its own custom rules. So in here, I give it an order. It must be bigger than the min value of integer or the max value. I don't remember the order. But like, if you put an order, it's going to be picked up before this filter chain here. So I can call it HTTP basic filter chain. Calls in HTTP security, HTTP, right? HTTP, and then throws exception. No Vim bindings, by the way. HTTP.build in the end, right? We do this. And so in that list of rules, we'll have authorized HTTP request, auth.anyRequest, authenticated, right? And then I'll want HTTP basic to be turned in. And I want these rules only to apply to anything under HTTP basic. This happens with the security matcher. So this says the entire set of rules that I've designed here will only be basic, valid for whatever matcher I put here. So it can be a request matcher or just a list of strings. So it's going to be HTTP basic / ***. So anything under HTTP basic flies with this. And I can even do like, oh, session. Well, since it's HTTP basic, well, you know, session management, no sessions here. Session creation policy, stateless, right? And so these rules only endpoints HTTP basic. And the rest, this is the last filter chain. It catches all requests. So this, if you send a request, say, to API, it doesn't match this security matcher, so it will go here instead. And so now I can go and clean up the mess I did with HTTP basic. So remove all of this. Boop. Remove HTTP basic here. I don't need that. Remove this authentication detail source. And now HTTP basic is only here. So again, I should be able to call this request with HTTP basic. That works. If I go as Daniel here, it knows it must be an HTTP basic authentication. So it doesn't redirect me to the login page. It just prompts the beautiful 1998 dialog for my HTTP basic authentication. So my browser can send their headers. So I've segregated the rules between some use cases and others. So if you have an API endpoint that is only through a JWT token that you can authenticate, you do a filter chain for JWT or for API, and then the rest is, if it's under, say, web, then you do another filter chain with a form login that you can use. OK, so TLDR of that. Think when you're designing your authentication, what information do I need? When is this information available? How can I capture it and keep it in my context? So maybe in a database, maybe in your authentication objects. That really depends on your use case. I cannot do 5 million use cases, but you can come to me after the talk, and we can discuss your own custom perverse ideas of security. Lastly, context matters a lot, right? And so you can separate your context and have dedicated security filter chains to have certain use cases. So your information gathering will be simpler. You're going to use the default. You'll have simpler rules. But please do not create 65 security filter chains that fight with each other to know which requests should be, which filter chain should handle the request, because you're going to create a different kind of monster. If you've ever done microservices, this is microservices, but for security. So don't do that. So some of you are still awake. Congratulations. If you would like to see this code for yourself in a human followable manner, you can go to this repository, find me on the internet, send me a message, talk to me after the conference, go in the conference app, leave me some feedback. It takes 5 seconds, and I'll be very happy. And if you take 25 seconds to leave a little message that tells me what was good, what was not so good, so I can make it better, you'll have my eternal gratitude. That's all for today. You're now allowed to go get a beer. Thank you for your attention. Goodbye.